Hey, hi folks. This is Yusuf Rangwala here, and welcome to Future Ready App Summit. In this session today, let me go ahead and take you on a tour of Azure Kubernetes service. A little bit about me. I am a principal specialist, part of the global black belt team. I have been working on the Azure cloud for about 10 years, and I've been helping customers, build complex applications, migrate them on various platforms, including Azure Kubernetes services. You can reach me on my email address at yusuf.rangwala@microsoft.com, or you can also, find me on LinkedIn or on Twitter with my handle, Where is Yusuf. I love reading. I'm a technologist. I love discussing technology. So if you find me anywhere, let's catch up and we'll be happy to talk. In today's session, we've done this session a lot of time. Uh, we've already done some best practices in this. So today, what I'll do is I'll do a little bit of slides where we just go ahead and cover some aspects of what we have and then jump right into action and show you some of the tidbits or things which are lesser known that can really help you kind of take your applications to AKS in a much seamless streamlined manner. So with this, let me start off why first. Well, Kubernetes is now here to stay. It's probably one of the most sought after platform, and I mean, kind of everyone wants it, right? It's a new big thing. It definitely solves a number of problems, especially around agility, especially around deploying at scale, and also ensuring reliability and resiliency of your applications. However, it is complex. You do have a lot of things to take care of. So on one end, you have the control plane, which contains a lot of API servers, the controller manager scheduler, the HCD database, and all of that. And then you have your worker nodes where your kubelets, your proxies, and everything is there, and then your applications. And what we've heard from customers is it is complex to manage, and it kind of is now started to become like the next big hairy thing. And hence, if we reduce the complexity and go ahead and give you a completely managed control plane, where we take care of the entire master aspect of it, and then we also give you a way for you to just go ahead and deploy your applications. It kind of takes a lot of your complexity out, and then helps you kind of build great applications. So with this in mind, that's where we came out with Azure Kubernetes Service. Obviously, the thought process was highly reliable, extremely secure, self-healing. There are a number of additional features that we give, which can help you reduce your overall burden of how to go about managing a complex orchestration engine, and just focus on your applications. So now let's go ahead and look at what we offer you, right? And the first thing that I would want to talk about is cluster creation. So the simplest way to go about creating a cluster is like AZAKS create, like just one command, and you will have a cluster up and running for you. Do remember, this is just a cluster that you can play around with, because when you are creating a cluster for your enterprise applications, you will need much more things than just AZAKS create. But then the whole thought process is you can add all of those features in the command line and then start creating clusters based on whatever requirements you have. And I'll talk about, or we'll probably see those in action when we go into in the later part of this session. We also give you an extremely great portal experience, so that just like how you create all the other Azure resources, you can create AKS through portal via the standard GUI interface that we have. And we do not stop there. We also give you an ability to create Kubernetes clusters using infrastructure as code. And whether you want to use the traditional ARM templates, or you want to use Bicep, or maybe a third party, tool like Terraform, we give you support for each and every one of them. Now, whatever tools you use, in the end, the Kubernetes cluster would be created same. There would be some preview features which would not be available on the portal, and hence you may have to go to the CLI to do it. But then, those are the ones that, you should be worried about. I mean, you should just think about it. Now it comes to applications. And again, we give you a way to manually deploy those application deployment files, the manifest. And, like for example, you can use YAML, you can use JSON, whatever upstream Kubernetes supports, we go ahead and support that. And you just have to connect to your Kubernetes cluster and deploy them. You can also use Helm to do this. And by the way, you also have the Azure portal where you can go ahead and deploy those files manually. But then, if you really want the best power of Kubernetes, is to use DevOps. Because with DevOps, what you can do is, kind of put all of your deployment manifest into a source control, and then use, the CD engine, the continuous deployment engine, to go ahead and deploy these containers into the Kubernetes environment in a repeatable, automated, and agile manner. And for that, you can use Azure DevOps with Azure DevOps pipeline, because we already give you support for Kubernetes, and then you can go ahead and kind of directly connect to it. You can also use GitHub with GitHub Actions, and probably if you have any third-party CI/CD tool, those works as well. Jenkins or whether it's GitLabs, all of those will work with AKS. You just need a way to connect to those systems. The third, and probably one of the newer ways of deploying your applications, is to use this concept of GitOps. And with GitOps, what happens is there's an agent or tool which is inside of your cluster, and it keeps on checking for changes in the container registry. And as soon as it finds that, it'll automatically start the deployment for you. And that means you're not even worried about triggering those pipelines. It's a complete end-to-end automated solution. We do have Flux and Argo CD that we've seen customers use it. But then, again, the choice is entirely yours. Now, if you look at from a monitoring perspective, you do have a lot of options of monitoring your clusters. Now, you can go for something which is inbuilt on Azure, like we give you an ability to monitor using Azure Monitor and Log Analytics Workspace, wherein all your metrics as well as your logs, application logs, cluster logs, diagnostic logs, your Kubernetes logs, everything can actually go into a single workspace. And then we give you ability to query, to create charts, to create alerts, to visualize. So all of this is available to you via the Azure Monitor and the Log Analytics Workspace. However, if you want to go for something which is more open source, you can go ahead and deploy Prometheus inside of the cluster, and then Prometheus can start kind of picking up those metrics, and eventually it can be tied to a Grafana interface so that you can visualize and kind of set up the necessary charts or whatever is required. On the log space, we've also seen customers actually either use something like a Logstash or a Fluentd, which can go ahead and start picking up those logs and then pipe it to an Elasticsearch database. And then eventually, for visualization, you can use Kibana. Now, there are so many such open source solutions that you can use, but then you can also go for some of the paid or premium solutions that give you an ability to monitor as well as kind of metrics as well as logs for a Kubernetes cluster, and that works with AKS as well. So you have Datadog, you have Splunk, you have Sysdig. I mean, there'll be tons of such third-party tools that you can potentially use. Now, here is an interesting bit. You can use Prometheus by itself, but let's say that you do not want to have the Prometheus server. You still have the Prometheus agent inside of your cluster. Azure Monitor gives you an ability to scrape those Prometheus logs, which gets generated inside of the cluster, and those can be shipped over into the Log Analytics Workspace. And that essentially means You are still capturing Prometheus data. The power of Prometheus is there, and the repository where the data eventually resides is the log analytics workspace. So it's like kind of best of the both worlds, because you're getting best of breed solution. You are also not managing the Prometheus server by yourself. You already have that being managed by Azure. In fact, we also have a managed Grafana service. If you only do not want to install Grafana, so you can use that managed Grafana service and tie it to a Prometheus source, so that you can start visualizing whatever metrics that comes out from Prometheus. We also have a managed Elastic service with our partner Elastic, and if you want to use that, you can potentially use that, and then have your AKS logs, and if you're using metric beats, your metrics also piped it to Elastic, and then kind of use the managed Elastic service for doing that. So yeah, in a nutshell, there is a lot of options, and there's a lot of flexibility that you have. You choose and you decide how you want to go ahead and monitor your Kubernetes cluster and your applications. Now it comes to management. We've taken a pretty interesting stand. So for example, uh, we do give you an ability to kind of scale automatically by using something called as cluster autoscaler. But then we also have something called as virtual node, which essentially means you can do serverless scaling. And means that based on your individual pods that come up and that require, you go ahead and spin up individual instances, container instances, which will be for that particular pod. And that's where you can kind of take care of any burst scaling scenarios. You don't have to worry about the underlying nodes at all. Everything is behind the scenes taken care of by us. You also have the ability of ensuring availability by uh, by using the availability zones of the Azure regions, so that your cluster can have better availability as compared to without the availability zones. And here is the flexibility. You can decide on which zones you want your cluster to be in. You can decide on how many zones you want your cluster to be in. And then if you want to go and fine grain it at the node pool level, you can even decide which zone a particular node pool can be deployed in. So the flexibility when it comes with availability zones is like to the maximum level. You decide the way that you want to do it, and then that will give you the necessary availability guarantees. In fact, what we've also done is we have ensured that the paired region concepts can be applied to AKS clusters, so that if you want to do your disaster recovery, you can always set up two AKS clusters, and then kind of switch between them as well. We also give you very interesting recommendations through our diagnostics and advisor, through which what happens is that you can get like recommendations. Let's say if your applications are using an API which is deprecated, we can go ahead and alert you in advance, so that you can start making changes to your application deployment files. If let's say there are applications which are having a lot of out of memory, because that comes up as in our diagnostics, we can go ahead and highlight those across to you, so that you can start kind of taking the necessary actions. There's a lot of insights that is available to you once you start picking this up. We also give you an SLA based option, where if let's say you want to go for an uptime SLA, we will then ensure that even the control plane is spread across, and there's a guarantee of the uptime on the control plane apart from the data plane. The data plane by default, because they're running inside of VM scale sets, give you the necessary guarantees that you get with availability sets or availability zones, which is there. And last, we give you an ability to manage cost, whether it is via something called as spot VMs that you can add inside of node pools. You can create a node pool with spot VMs. You can also stop and start an entire AKS cluster. as well as you can actually go ahead and stop and start a node pool if required. Some interesting other things that we've added for developers is an ability to scale via KEDA, which is Kubernetes event-driven architecture. So that essentially means not only on the metrics that are given by Kubernetes, but you can go ahead and tie it to external events, message queues, something which is inside of Kubernetes as well. You start creating the necessary triggers, and then you start scaling your applications and eventually your cluster through KEDA. We give you a way of integrating with various uh, other services using Dapper, and then we have the ability of scaling not only via the metrics which Kubernetes provides, but you can go ahead and tie it to external events like a message queue, like the number of requests that you're getting, or something which is happening inside of the Kubernetes cluster as well using KEDA. We can also integrate with other services so that your application doesn't need to worry about changes in maybe the message queuing service by using something like Dapper, so that a lot of those integrations are completely taken care of by the Dapper runtime, which can sit along with your applications outside. And then last, if you want some of the advanced features in terms of observability, in terms of security, like mutual TLS between service to service communication, you want an advanced traffic routing patterns like canary deployments or circuit breakers, you can use service meshes. We give you an option of using any of the third-party service meshes, whether it is Istio, whether it is Linkerd, or you can use our open service mesh just out of the box, which is available. Uh, then let's talk about security. And we've taken a pretty broad idea about security. If you look at it, our security approach has been on at 4 levels. The first is, image and container level security, where essentially you go ahead and secure the Azure Container Registry. You can control who accesses it. You can control who, you know, uh, how various namespaces and those scoped as the scope of then you can actually give. I'll repeat. You can control who gets access to the Azure Container Registry, and you can also go ahead and put it behind a private virtual network. You can also ensure that images that come or get deployed to the registry are scanned for vulnerability and like ensure content trust for image validation. The second aspect is, when you look at inside the cluster, when you want to look at cluster and node level security. So behind the scenes, we are making sure that the underlying node OS is applied with a lot of these hardened policies. All of them comply with the CIS benchmark. Uh, and then we do run nightly patches on a regular basis. We also give you an ability to control what is the kind of network access inside of Kubernetes that you can get by using network policies. And then you can also implement policies which are more fine grained for the deployments or the pods by using something called as pod security policies or gatekeeper now, and that is tied with Azure policy. Overall, the cluster can be tied with Azure AD so that whoever is accessing it, their access levels can be controlled by Azure AD groups. And you can also define RBAC at the Azure level or inside the Kubernetes cluster level, whatever options you have. From I already talked about pod, where you can associate an identity to individual pod. It is called as workload identity, and then whenever that pod needs to access any external resource, you can validate whether it kind of brings that identity, and only pods with the identity should be allowed for accessing, let's say, a SQL database or a key vault. And anyone who doesn't have that, you can go ahead and reject it, which essentially means inside the Kubernetes cluster, you can go ahead and start giving finer controls. The last, I mean, you can also define various security contexts inside of your pod. so that you're ensuring that what privileges the pod runs under, what are the kind of rights that you are giving to that particular pod, and you are controlling, right, how the pod behaves. Now, we have also worked with Azure Security Center so that you can start kind of looking at runtime security of your Kubernetes uh, cluster, and if there are any kind of incorrect anomalies, it gets highlighted as early as possible. Now, at the node level, we also give you an ability to encrypt the disk OS or any storage using we already do it by default for platform using platform managed keys, but then we give you an ability to kind of have customer managed keys as well. And then from a perimeter perspective, you can put firewalls for controlling egress traffic. You can put a WAF for controlling ingress traffic. In fact, we also have something called as an application gateway ingress controller, which can kind of double up as an ingress as well as kind of be used for kind of securing your incoming workloads. The next thing that I want to talk about is a very unique command called as repeat. The next thing I want to talk about is something is the command line, and there are like tons of commands which are there. Whatever you can do on the portal, you can do it via the command line. But then I thought there are some of these ones which are really good. The first one being AZAKS add-on. You can pretty much use it to disable and enable add-on, and I'll cover the add-ons that are available to you subsequently. You also have something called as draft, and this is in preview, but essentially what you can do is you can tie up your source code, and by using draft, we can help you create the containers and then create the deployments for Kubernetes automatically. In fact, if you want to create like a full end-to-end workflow, we can do that. And it gets integrated with GitHub using GitHub OIDC. So which means, you just run this command, you go ahead and connect it with your GitHub repository, and then, you can have like an entire, your application can be deployed automatically from your source code. We also have a way, and especially this comes in helpful for private clusters, wherein you can invoke a Kubernetes command, like a kubectl command, using AZAKS command. You invoke those commands using the invoke, and then you can view the results using the result part of it. And the last part is, in case of an issue, we have this thing called as AKS Periscope, where you can start collecting diagnostics information from the cluster and kind of store it at a storage account. And then this can be used for kind of doing an analysis of what happened, right? So because we give you the ability of collecting those logs and collecting those diagnostics so that you can start thinking about it. And you can obviously give it to our support functions as well so that it helps them as. Quickly talking about the add-ons, we have an HTTP application routing, which essentially I would not recommend this for production. The idea is, it give you an automatic public DNS to configure your endpoints. Monitoring, which is like what can you use for tying it to Azure Monitor and the Log Analytics workspace. You have to provide the workspace resource ID. Virtual node, I talked about it. You can go ahead and enable that so that virtual node can be spun up as and when required. There is an add-on for Cube Dashboard. Again, I would not want to recommend that as well. You can enable Azure policies, which, I think I spoke about it. It ties up with Gatekeeper and kind of uses the open policy agent so that, this add-on will now start, introducing Kubernetes specific policies inside of your cluster. You can set up an ingress application gateway ingress controller just by, creating this add-on. Concom. The idea is, if you want to do confidential computing and you want to make sure that the Intel SGX plugins are kind of, installed on the underlying nodes, you can go ahead and enable this. Again, this is in preview, but then do remember, this only gets applied to the Intel-based virtual machine SKUs. But then this is really important if you want to enable workloads that require confidential computing. Open Service Mesh, this is what can be done for, I talked about Open Service Mesh, you can enable it out of the box. We also give you an Azure Keyword Secrets provider so that when you want to integrate your workloads with Azure keywords, that happens out of the box. And then we give you an ability to enable GitOps, where the Flux instances are created out of the box. Now I think we do Flux v2. And the last is web application routing, where essentially if you want to go ahead and kind of expose your ingress in a secure manner, you can just enable that, and we will enable web application routing directly out of the box. You do not need to create an ingress controller resource yourself. Last section is on the reference architectures, and this is available on the documentation, but I just thought I'll kind of give you a glimpse of what's there. You can always go there and read through and kind of take help from those things. So this is like a typical microservices architecture, where you deploy your backend services in a namespace. You have your utility services in another namespace. You have an ingress, which is front ending it to an Azure load balancer, where your client applications perform, and then you have your pipelines, which is either through Helm or through your normal application deployments, or doing CI, where they're pushing it to container registry, and then eventually using Helm they are doing CD into the Kubernetes cluster. Obviously, you can go ahead and tie up the Kubernetes cluster with an Azure AD, Azure Monitor, and Azure Key Vault. And there are external stores, whether it's Cosmos DB or SQL, Postgre, any of these managed databases, you can go ahead and connect directly. A little bit of an enterprise microservices architecture. Most of the internal thing remains same. Just a few more things. You can ensure that your egress is or everything is routed via an Azure firewall, via the hub and spoke kind of setup on networking. You can also ensure that my Kubernetes cluster is private, and that essentially means when I want to connect to it, I'll have to use something like an Azure Bastion to connect to the Kubernetes server to make deployments. And then when I'm connecting to any of the external databases, they will also be available only via kind of a private link setup. The last bit. So the next one is, we also have something called as Magento on AKS. Magento is a very good e-commerce platform. So we give you how you can go ahead and set up your Varnish pods, your Magento pods, your Elasticsearch and Redis that is required, and how they can kind of work out inside of a Kubernetes cluster. And obviously the static images and everything is still coming out of a CDN, which is Azure CDN. Again, from a cluster perspective, the setup is very simple. It is just that how your internals kind of vary. And then next is, in case if you have regulated workloads like PCI, DSS requirements, you can actually go ahead and set up a very secure Kubernetes cluster, where even like when you're building images, they are coming in a much more secure manner. You have your application gateway for WAF. You also have inside a lot of your agents, build agents are also sitting inside of your cluster, because you cannot have like an external service talking to it. Here is where something like GitOps makes absolute sense, because now you're controlling all your connectivity is always outbound, nothing is inbound, which is there. You do have your key vaults and container registry and other data sources all through a private link, and whatever is coming from the public internet is extremely kind of secure. In fact, we've seen you will have different node pools, and you will start making sure that you kind of secure those node pools in the right way. You can also add in additional controllers, admission controllers, to make sure that every deployment is validated in terms of what is getting deployed where. Okay, so let's now get into some action and see what we can possibly do using AKS. So I am on the Azure portal. This is the list of Kubernetes servers, but let's go through the Kubernetes create experience. So when you go ahead and create a Kubernetes cluster, you do have to provide the standard things that Azure asks you, like a resource group, like the region on which you want to deploy it on, like availability zones, which ones do you want, what is the Kubernetes version, and what is the availability SLAs that you want to look at. Let me just go ahead and pick up like, any random numbers. I'm not going to create the cluster, and then we'll see how it works out. Now, remember, you do get versions that you have. So, because 24 is the current minor version, you do get backward compatibility with 23 and 22. If you have any clusters earlier than 22, you'll need to upgrade them as quickly as possible, or the SLAs will not work. So what we've seen is typically you should be doing an upgrade operation every 3 months, which is upgrading of the minor versions. The patches, however, are more frequent. It all depends on what functionalities and what features we keep on adding. And needless to say, the patches will be okay. So you should be upgrading the patches more frequently. I did talk about auto upgrade that you can use to configure so that the patches happen automatically out of the box. You decide on the node size, which is like the VM's queue, and you can obviously change it. You also decide whether you want manual or auto scale, and then you define the number of nodes that you want to do it. Now, obviously, this is just the primary node pool, which kind of gets associated with system. Let me go ahead and look at this. If you look at the compare prices for this one, right, we give you these standard presets which you can create. So for example, if I'm doing a dev test operation, I only need like a single node pool with like a burstable, CPUs. But if I want to do batch processing like machine learning or any graphic processing, right, I need an N series here. But I also need for hosting my system processes, I need like a system pool. And then if let's say I'm doing something like a hardened access, right, I might go with a D4 D series VM, which eventually can be used for protecting it further. So depending on what your usage is, you can go ahead and select the right presets. You can change them any point in time. So it's not that you cannot, because what you get is an ability to add node pools. So when you have your node pools, you can again decide at the node pool level which zones you need to come up at. Whether you want spot instances, this will generally be applied to the second node pool onwards. The first one will be the system node pool. So you can decide the other ones, which will be user ones, you can do that. And then you can define your auto scale at the node pool level. Now, one interesting aspect is the max spots per node. This comes in very helpful when you're doing when you're using Azure CNI as your networking interface. And depending on the number of pods you define, the number of IPs that we will need on the subnet would be put across this. So for example, in this particular case, with 110 pods per node and 5 maximum nodes, I need about 550 IPs in my cluster subnet, which is there. Or what I can, and probably I need another 5 IPs for the node as well and for load balancer. So if I don't have that much and I want to use something which is less, I can reduce it to 30, in which case I probably need about 150 IPs. I can specify some key value pairs and taints. If you know Kubernetes states and tolerations, I can go ahead and specify them here as well directly. Now, the next thing you can do, remember encryption with platform managed keys and customer managed keys, which is there. I can define the access level and I can integrate it with Azure AD and decide on whether I want to use the traditional Kubernetes RBAC, where I will end up creating the role bindings and the roles inside of the Kubernetes cluster, or I can go for Azure RBAC, where I have built-in roles available. Okay. Once I decide on any one of these ones, I can go and select networking. Just a good point. If I have selected Azure AD, I can choose a group which can be the cluster admin, so that that cluster admin role binding only goes to that group. And this is required because if you don't have that, you will end up not having any cluster admin access for it. You can do this later on by through the CLI, but yeah, I would suggest you do it at the time of creation of the cluster. Networking, like you said, we give you out of the box two ways of setting up networking. One is kubenet, where the individual nodes get IP addresses, pods IP address is abstracted, and then kubenet kind of handles it behind the scenes. This means that whenever you need, like, discovery of those IP addresses and stuff like that, you will need to kind of do additional management and routing. If you go for Azure CNI, every pod gets an IP address from the subnet, and that helps you great. But then, yeah, obviously, you will exhaust the number of IP addresses very quickly. There are the settings that you need to go ahead and create. You can enable a private cluster, or you can set up authorized IP ranges if you still want to continue with a public API access, and ensure that only a few IPs can connect to it. And last, network policy, I can go ahead and define whether I want to go with Calico or Azure. With KubeNet, Calico is the only option available. With Azure CNI, you can go with either ones. Do remember, Windows containers again work with Calico only. When you set up a network policy, you cannot change it. Make sure you pick that up at the time of creation of the cluster wisely, or you'll have to recreate the cluster with the new network policy settings. The next thing is you can attach an Azure container registry, where essentially what you do is, what we do behind the scenes is we integrate, we kind of create an ACR pull role and make sure that that is provided to the Kubernetes cluster, so that the container registry understands whenever a request comes from this cluster, I'll allow them to go ahead and pull images from myself. So some of the integrations we have is Azure Container Registry, where essentially I can integrate it with a cluster, so that the cluster's identity will already have an ACR pull role with the container registry, and that means the container registry can allow pulling of images from this ACR. I also have integration with Azure Monitor and then Azure Policy. I think I've already spoken about it before. We can enable the secret store CSI driver, so that essentially when you integrate with Azure Key Vault, it's easier. And if you want to modify the underlying infrastructure resource group, you can do that. This generally is required when you have a particular naming convention that you want to follow for all the resources that gets introduced. Finally, when you do a review and create, we just do some basic checks and then help you on the creation. Obviously, mine failed because of the access. Let me go ahead and switch this across, and then go on review and create, and then it will go ahead and pass that across. But as it is, I'm not going to create the clusters right now. So I'm going to cancel this, and let me go to my cluster here. Now, this is a private cluster that I've created. I just want to show you and walk you through what all is possible on this cluster. So if you go onto this cluster, you see the overview where you see the API address. And if I go ahead and look at this address, I will not be able to kind of reach it. I have the Kubernetes version, I have the network type and the node pool, and with subscription and the standard details that I have. I have some high level properties in terms of what is a node pool, what is a networking address, or what is the configuration that I have. And then I have some monitoring and recommendations that I can look at it from here itself only. If I really want, like I said, I have the standard Azure parts, but let's go to my infrastructure access control, IAM. But let's go to IAM. And here, what I can do is I can add a role assignment. And if you look at the various role assignments, I have these role assignments specifically for Kubernetes. So I can define a cluster admin, I can define a user, I can even scope it to namespace. And for that, you'll have to go to the command line. But if, let's say, you want somebody to have reader access on a particular namespace, you can do that using the Azure Kubernetes Services RBAC reader scenario. So you go ahead and select the right built-in roles, and then you can scope it to a namespace, and then you define it there. Alternatively, you can go the traditional route and define roles and role bindings inside of your cluster as well. The next interesting thing that I want to show you is diagnosing and solving problems. We give you an ability to check for issues inside of your cluster. So for example, if any of your pods have been killed, you will be able to find those here. If, let's say, there are any deprecated APIs that any of your manifests are using, you can actually go ahead and look at that here. We also give you, and I'll go back because you can start looking at those things, but For example, let's go ahead and double click on this one, right? We see that there have been some resource request throttling, and uh, what this means is, let me go back. Not sure what happened. So with this, you can go ahead and using the diagnose and solve problems, you can find out any pods that have been killed, any APIs in your manifest that have been deprecated, and let's say if you have any resource requests that have been throttled, or any node issues, you can go ahead and find them here. I mean, because I don't have those issues right now, I'll not go there. But essentially, you can also analyze your cluster for best practices, and see whether you've been following some of the best practices that we tell you, with respect to subnet capacity, with respect to, let's say, if you specified any incorrect pod disruption budgets, have you set up the right request and limit values inside of your manifest for CPU, memory, and those things, right? So you can go ahead and start looking at those aspects as well very easily. Moving on, we give you a user interface for looking at your namespaces, your workloads uh, that you have, uh, and the service ingress that you've created. So you can go ahead and have a look at all of those ones. The next thing we give you is an ability to configure node pools through the screen, as well as see what's there. Uh, I cannot change the networking interface, but I can definitely go ahead and look at like upgrading the cluster. When I go ahead and click on upgrade, I have the option of deciding which upgrades I want to go to, and then whether I want to upgrade only the control plane or the control plane and the node pools. A risk averse way is where I upgrade the control plane, and once that upgrade is completed, I go back to the node pools and then upgrade the node pools individually here. Okay, so once the control plane has been upgraded, you can come here and select which version do you want to upgrade to, and that means I'm only upgrading a specific node pool. That ensures that in case if there were any failures, not everything is impacted inside of my Kubernetes cluster. I can do integration of Open Service Mesh as well as GitOps here directly, and we also have the automated deployments, which is where I can kind of uh, synchronize it with a Git bond. I can integrate with Azure policies, and once I enable this add-on, and then I come to the monitoring aspects. If I look at monitoring, what we give you is, if let's say you've integrated with the Azure Monitor, obviously this one is not. Let me go to another Kubernetes cluster where I would have integrated with monitoring. Let's see this, or let me go to this one. Let's see the insights. So in this one, I would have some workloads, which would mean I would see some data. So I've got my node CPU utilization maximum at roughly around 40%, or an average of 30 to 35%. My minimum is 20%, which is the node CPU utilization, as well as the memory one. I also see how many nodes are there and how many pods are running. So there are like about 38 pods which are running inside of the cluster. But we don't stop here. What you can now do is go into individual nodes and see how the nodes have been performing. Now, if I go ahead and take this last 3 days, because I just created this cluster like about 2 days back, I'll see that one of the node was running for a longer duration, and then it started having some CPU. I've obviously set up certain kind of parameters of when it will scale, and because of that, it started scaling, and I have a new node which was created about 11 hours before. So I can see that I can decide on what metrics I want to see, whether it is CPU, memory, whatever I want, and then whether I want average or 95th percentile or whatever is there. When I click on this node, I actually see which pods, which services, which pods are actually running, which deployments are actually running inside of those clusters. And then I can go at an individual container level and see the same details. So for example, if I want to see how my application is behaving, I can do a filter based on service. And let's say I want to see how my ratings API is behaving, and I'll see how my ratings API failed. Obviously, there was a warning and there were some issues that I have. I can go ahead and see that here. Uh, Now, this is not running currently, and hence, I'll not have it. But let's say if there is an API pod which is running, I can look at live logs which gets generated on that particular API, as well as any live events that gets generated on the particular pod. So I have the ability of doing it directly via this interface. Needless to say, those logs and events do get captured in our centralized log analytics workspace, and you can access it from here. uh, Now, if you open up, we give you these standard out-of-the-box queries for Kubernetes. I'll pick up the most simplest one with respect to container logs. So, for example, if I want to find a particular value inside of the container log, I'll give you those queries here. And then let's say if I want to see error, that if was there any containers which had kind of shown that there is an error, and if I see some errors generated, I'll be able to see that in the log. I'll just hide it here. See, they have been piped to my STD error logs. And if I want to see the entry, there was a handshake error, TLS handshake error between, a particular pod and the other one, because I'd set up like TLS and how that was happening. So depending on what I have configured and how I'm doing it, I'll see these errors which are generated inside of the logs. Now I do have an ability, just like how the other alerts happen, I can go ahead and configure alerts into my Kubernetes cluster. We have the idea of enabling recommended alerts. And then if you want to create any custom alert rules, you can do that. In fact, using logs, you can also create custom alert rules. One interesting point that I will tell you is, if let's say you want some logs with respect to our API server, the control plane, you need to go onto this diagnostic setting and click on add diagnostic setting and select which components of your API server you want to go ahead and capture the logs, and how do you want those logs to appear. You can send it to a log analytics workspace, which could be the same one. You could save it to a storage account, you could stream it to a event hub, or send it to a partner solution. So this helps you ensure that even the control plane logs are captured by you, and then piped it to the right place. With this, I think I've kind of walked you through what you can possibly do on the portal, what you can, how you can kind of create. Hopefully this was helpful for, kind of you to take your Kubernetes journey further. So summarizing, Kubernetes on Azure is an extremely powerful tool. It's obviously enterprise grade by design with a lot of built-in best practices, and we give you the right recommendations. Security is at multiple layers. You can decide how much you want to go through. We also give you the operational efficiency in terms of, the right alerts, the right notifications, and then it is tied to, our enterprise grade support, and then we give you the right governance mechanisms to go ahead and manage these clusters. I would suggest that you go ahead and try this out and see what can it do for you to build your applications and deploy them on AKS. If you want to see, what tools you can potentially use, we give you a whole, we integrate with a lot of open source tools. So with respect to development, if you want to use like Helm, Draft, or any of the IDEs, we give you DevOps toolchain, we give you monitoring toolkits. We also give you an option of bringing in your own CNI, and you can then manage it. Obviously, we don't manage those CNIs, but you can do that. And then if you want to go ahead associated with other open source tools for storage, for security, you are free to do that. We are tied to the upstream open source Kubernetes platform, and we follow them as much as possible. We don't have our own version. Closing in case if you want to, kind of look at various options, there is a learning path specifically for Kubernetes on Azure. You can look at those. There are tons of videos available which walk through each of these settings. We also have a roadmap in terms of what's coming on Kubernetes, and there are tons of case studies if you want to see what other customers have been trying out. And yes, you can always try for free using our trial offers, which is there. With this, I come close to this masterclass. I hope it was helpful for you. Thank you very much. Happy containers.